recall from General Motors. It involves 600,000 vehicles whose V8 engines can fail without warning.
The warning did not arrive quietly. It came like a siren in the dark, cutting through the noise of a world already drowning in recalls, supply shocks, rising repair bills, and drivers who thought their vehicles were safe until the moment the engine light blinked on and everything changed. By 2026, what had once looked like isolated mechanical trouble began taking on the shape of something much larger, something far more disturbing. A full-scale engine crisis with researchers, mechanics, fleet operators, and frustrated owners all pointing toward the same terrifying pattern. Engines were not merely wearing out, they were failing early, failing suddenly, and failing in numbers too large to ignore. Before we start, hit the like and subscribe buttons for more updates. For millions of drivers, the story began the same way. A car that seemed normal, a routine commute, a family trip, a delivery route, a truck hauling equipment. Then came the sound, a knock beneath the hood, a shudder under acceleration, a warning light flashing like a countdown. Some vehicles lost power on highways. Others stalled in traffic. Some drivers pulled into service centers expecting a sensor issue, only to hear the words no owner ever wants to hear: catastrophic engine failure. Not a cheap fix, not a simple adjustment, not something that could wait until next month. The heart of the machine was gone. And the most chilling part is not that engines fail. Engines have always failed. Machines break, parts wear down, oil gets neglected, heat destroys metal. But what makes the 2026 engine crisis so alarming is the scale, the timing, and the pattern. These are not just ancient vehicles limping toward the end of life. Reports suggest that newer models, low-mileage vehicles, hybrid powertrains, turbocharged engines, and heavily optimized fuel-efficient designs are all caught in the same widening storm. What once felt like random bad luck now looks like a structural problem spread across the modern automotive world. The modern engine was supposed to be a miracle of engineering. Smaller, lighter, more powerful, cleaner, more efficient. Automakers promised that advanced materials, precision manufacturing, computer-controlled fuel delivery, variable valve systems, turbochargers, direct injection, and electrified support systems would deliver more performance with less fuel. On paper, it looked like progress, but beneath the polished marketing and futuristic dashboards, a dangerous trade-off was taking shape. Engines were being pushed harder than ever before, squeezed for every drop of efficiency, every fraction of emissions compliance, every ounce of power from smaller and smaller displacements. That pressure changed everything. A compact engine that once would have delivered modest power is now expected to perform like a larger engine from a previous generation. Turbochargers force more air into cylinders. Higher compression ratios raise stress. Start-stop systems repeatedly shut engines down and fire them back up in traffic. Thin oils reduce friction but leave less margin when conditions turn brutal. Complex cooling systems manage narrow temperature windows. Direct injection can create carbon buildup. Timing chains, bearings, pistons, head gaskets, oil pumps, and sensors all live inside a harsher environment than many drivers realize. And when one part begins to fail, the collapse can spread fast. A slight oiling issue becomes bearing wear. Bearing wear becomes metal contamination. Metal contamination destroys internal surfaces, heat builds, pressure drops, the timing system slips. A piston scores a cylinder wall, a turbo starves for lubrication. A head gasket weakens. Coolant enters places it should never be. Oil turns dark with microscopic metal. The engine does not explode like in a movie. It dies in stages, each one more expensive than the last, until the repair bill becomes so large that the vehicle itself feels like a financial trap. This is why the phrase engine crisis lands so hard. It is not only a mechanical crisis, it is an economic crisis inside people's driveways. For the average driver, an engine failure can mean thousands of dollars overnight. It can mean losing transportation to work. It can mean choosing between repairs and rent. It can mean owing money on a vehicle that no longer runs. It can mean fighting with warranty departments, waiting weeks for parts, or discovering that a service contract has exclusions buried deep in the fine print. The engine is not just metal. It is mobility, income, independence, and security. The timing makes it worse. By 2026, vehicles are more expensive than ever for many households. New cars have climbed into price ranges that would have shocked buyers a decade ago. Used cars are no longer the cheap escape they once were. Interest rates, insurance premiums, part shortages, labor costs, and dealership markups have already turned vehicle ownership into a financial burden. Now add mass engine failures to that pressure and the situation becomes explosive. People are not just angry because machines are breaking. They are angry because they were told these machines were advanced, reliable, and worth the debt. The most dramatic reports focus on millions of failures already being counted across repair networks, consumer complaints, service records, warranty claims, and independent investigations. Whether every number is complete or contested, the pattern itself is what has people alarmed. Mechanics are seeing repeat failures in the same engine families. Fleet operators are tracking downtime that destroys schedules and profits. Researchers are questioning whether modern design priorities have outrun durability. Owners are comparing symptoms online and realizing they are not alone. The fear spreads because the stories sound too similar. First comes excessive oil consumption, then rough starts, then coolant loss, then misfires, then low compression, then metal shavings, then the final diagnosis, engine replacement. What makes the situation feel cinematic, almost unreal, is how invisible the danger can be until it is too late. A vehicle may drive normally for months while damage builds silently inside. The dashboard remains calm. The engine sounds acceptable. Fuel economy looks fine. Then one morning, the starter turns, the engine catches, and a harsh rattle echoes for just a second longer than it should. That sound becomes the first clue. A week later, the warning light appears. 2 weeks later, power drops. By the time the owner reaches a mechanic, the internal damage may already be irreversible. And this is where the crisis becomes bigger than individual blame. Yes, maintenance matters, oil changes matter, coolant service matters, driving habits matter. But if millions of engines are failing in similar ways, the question becomes far more serious. Are maintenance intervals too optimistic? Are oils too thin for real-world abuse? Are engines being engineered to pass laboratory targets while struggling in brutal stop-and-go heat? Are automakers relying on complexity that works beautifully under controlled conditions but becomes fragile after years of real traffic, cheap fuel, short trips, delayed service, extreme weather, and heavy loads? The modern driver does not live in a laboratory. They live in traffic jams, dust, winter cold, desert heat, overloaded family trips, potholes, delayed paychecks, and repair shops with 2-week backlogs. An engine that survives only under perfect conditions is not truly durable. It is a gamble wearing a warranty badge. The implications reach deep into the future of transportation. For years, the auto industry has been caught between two powerful forces: regulation and consumer expectation. Governments demand cleaner vehicles, buyers demand affordable power, comfort, technology, and reliability. Automakers respond by building engines that are smaller, more efficient, and more complex. But every gain has a cost. When engineering becomes a balancing act with almost no safety margin, durability can become the hidden sacrifice. The customer may not see that sacrifice on day one. They may see it at 63,000 miles, just outside warranty coverage, when the repair estimate lands like a hammer. That is the nightmare scenario at the center of the 2026 engine crisis. Failure just beyond protection. A vehicle survives long enough to avoid immediate scandal, but not long enough to meet the reasonable expectation of ownership. Drivers do not expect engines to last forever, but they do expect them to last long enough to justify the price. When that trust breaks, it does not break quietly. It becomes a public reckoning. Dealerships become pressure chambers. Service advisors face furious customers demanding answers they may not have. Technicians see engines stacked for replacement. Parts departments deal with back orders. Warranty teams argue over coverage. Corporate offices issue carefully worded statements. Owners gather documents, receipts, photos, and diagnostic reports. Every failed engine becomes evidence in a larger trial taking place across forums, repair bays, consumer agencies, and courtrooms of public opinion. But the impact does not stop with private owners. Commercial fleets may feel the blow even harder. Delivery vans, rideshare vehicles, work trucks, municipal vehicles, and company cars depend on uptime. When engines fail across a fleet, the damage multiplies. Routes are missed, contracts are strained, replacement vehicles must be rented, drivers lose hours, customers wait. A single engine failure is a repair problem. 1,000 failures across a fleet become an operational crisis. When businesses begin adjusting purchasing decisions because they no longer trust certain engines, automakers listen. They have to. There is also a dangerous ripple through the used car market. If certain engines become known for premature failure, resale values can collapse. Buyers start avoiding specific models. Dealers become cautious with trade-ins. Extended warranty prices rise. Lenders may reassess risk. A vehicle that looked like a smart used purchase suddenly becomes a ticking financial bomb. The people most vulnerable are often those buying used because they cannot afford new. They inherit the risk after the original warranty has expired, and when the failure comes, they have the least room to absorb it. That is what makes the crisis feel unfair. The consequences do not land evenly. Wealthier owners may trade out early. Large fleets may negotiate support. Automakers may quietly assist high-profile cases, but ordinary drivers can be left fighting alone, armed with service receipts and frustration, trying to prove that an engine should not have failed so soon. The machine may be broken, but the deeper fracture is trust. Researchers looking at the crisis are not just asking what failed, they are asking why the same kinds of failures keep returning. The answers may involve design stress, manufacturing defects, software calibration, thermal management, oil starvation, fuel dilution, carbon buildup, weak components, supply chain variation, or maintenance schedules that do not match real conditions. Each possibility is disturbing in its own way. A bad batch of parts is one kind of problem. A flawed design philosophy is another. And if the crisis is tied to the broader direction of modern engine development, then the implications are massive. Because this is not happening in isolation. The automotive world is already undergoing one of the biggest transitions in its history. Electric vehicles are rising, hybrids are spreading, gas engines are being refined for their final decades in some markets. Automakers are investing billions into batteries, software, autonomous systems, and connected platforms. In that environment, the traditional combustion engine may be receiving a different kind of pressure. It must remain competitive, cheap enough to build, clean enough to sell, and powerful enough to satisfy buyers. That pressure can lead to aggressive engineering decisions. The result may be an engine that looks brilliant on a specification sheet but struggles as the years pile on. A tiny turbocharged engine with impressive horsepower. A hybrid system that constantly cycles operation. A start-stop system that reduces emissions in testing. A long service interval that lowers advertised ownership costs, a lightweight component that saves fuel, a compact cooling passage that improves efficiency. Each choice may make sense alone. Together, they can create a machine with less tolerance for neglect, heat, poor fuel, oil breakdown, manufacturing variation, or hard driving. And real life always finds the weak point. The public reaction is fueled by one brutal question. How could this happen when vehicles are supposedly smarter than ever? Modern cars monitor tire pressure, lane markings, blind spots, driver attention, battery state, emissions, fuel trims, ignition timing, and dozens of internal systems. Yet many drivers still find out about engine destruction only after the damage is already severe. That contradiction feels absurd. A vehicle can warn you about a slightly open fuel cap, but not always protect itself from the slow death of its own engine. That gap between technological promise and mechanical reality is where outrage grows. There is also the emotional shock of losing faith in something people depend on daily. A car is one of the most personal machines in modern life. People name them, work from them, eat in them, drive children to school in them, escape bad days in them, cross states in them, sleep in them when life gets hard. So when an engine fails without warning, it feels like betrayal. Not just by the vehicle, but by the brand, the dealer, the advertising, the engineering, and the entire system that sold confidence as part of the package. That betrayal becomes especially powerful when owners believe they did everything right. They changed the oil, they followed the manual, They used recommended fluids, they kept records, they did not race the engine or ignore warning signs. And still, the failure came. For these owners, the crisis is not theoretical. It is sitting in a service bay, hood open, engine apart, while someone explains that the repair may cost more than the vehicle is worth. The crisis also raises uncomfortable questions about sustainability. The cleanest vehicle on paper may not be so clean if its engine fails early and requires replacement, scrapping, shipping, machining, and rebuilding. Durability is part of environmental responsibility. A vehicle that lasts longer spreads its manufacturing footprint over more years and more miles. If modern engines are failing prematurely, then the industry's environmental math becomes more complicated. Efficiency gains mean less when engines become disposable sooner than expected. This is where the 2026 engine crisis becomes more than a consumer scandal. It becomes a warning about the cost of over-optimization. When industries chase targets too aggressively, they sometimes create systems that are efficient but fragile. Aviation, energy, software, finance, and manufacturing all know this lesson. Remove too much redundancy, narrow every margin, accelerate every cycle, and the system may perform beautifully until conditions shift. Then the weakness reveals itself all at once. Engines are no different. Metal has limits, heat has consequences, pressure must go somewhere. The most suspenseful part of this story is that many drivers may already be operating vehicles with early-stage damage and not know it. Somewhere, a bearing surface may be wearing faster than expected. Somewhere, oil is thinning with fuel dilution. Somewhere, carbon is choking airflow. Somewhere, a timing component is stretching. Somewhere, coolant is beginning to seep. Somewhere, a turbo is spinning on borrowed time. The engine still starts. The radio still plays. The commute still happens. But beneath the sound insulation and digital displays, the countdown may already be running. That fear changes behavior. Owners begin listening more carefully at startup. They check oil levels more often. They search symptoms at midnight. They question every vibration. Mechanics become interpreters of anxiety, trying to separate normal operation from early failure. Used car buyers become detectives, asking for service records, engine codes, oil analysis, and warranty history. Brands that once commanded loyalty now face suspicion. The crisis turns every unusual sound into a possible omen. For automakers, the implications are severe. Brand reputation is built over decades and damaged in moments. A company can survive a bad model, a recall, even a public controversy. But widespread engine failure cuts deeper because it attacks the core promise of a vehicle, that it will move when needed. Safety features, luxury interiors, touchscreens, and advanced driver assistance cannot compensate for an engine that destroys itself. Once consumers associate a brand with catastrophic failure, the stain can linger for years. There's also the question of accountability. If the failures are tied to known defects, consumers will demand repairs, reimbursement, extended warranties, recalls, and transparency. If the failures are blamed on maintenance, owners will demand proof. If the truth varies by engine type, model year, region, or driving pattern, the public will demand clear explanations instead of vague statements. Silence will not calm the crisis, neither will technical language that sounds designed to minimize responsibility. People want to know whether their engine is safe, what warning signs matter, and who pays if it fails. The industry now faces a defining test. It can treat the crisis as a public relations problem, or it can treat it as an engineering emergency. The first path leads to denial, delay, legal battles, and deeper distrust. The second, Tiguan new features and design. We want to hear from you. Thank you for watching and see you next time.